Hi there, my name is Tawfiq Omar Uthman. In our video for today, I'll try to explain Chapter 4, Lesson 3, Part B, Infinity Limits at Infinity. Please do not forget to subscribe the page and write your comment if you have any question and push a like button. And there is a link for exercise of this lesson at the bottom of the video, at the description of this video. Download it and use it carefully. Definition of infinity limits at infinity. The statement limit when x approaches to the positive infinity, fx is equal positive infinity, means that the value of fx increasing with no bounded as x increasing with no bounded. The statement limit when x approaches to the positive infinity, fx is equal minus infinity, means that the value of fx decreasing without no bounded as x increasing with no bounded. Similar definition can be given for the two statements. Limit when x approaches to the minus infinity, fx is equal positive infinity. That means when x approaches to the negative infinity, that means when x is become smaller and smaller, the fx is approach to the positive infinity. That means fx become bigger and bigger. The second one, and the limit when x approaches to the negative infinity, fx is equal minus infinity. That means the function f of x is become smaller and smaller, or goes to the negative infinity when x approaches to the negative infinity. This type of function, maybe they have a slant asymptote. Example number 5. Find each limits. A. Limit when x approaches to the positive infinity, x cubed. As you can see here, the function x cubed, its degree is odd and its leading coefficient is positive. So when x approaches to the positive infinity, x cubed is approached to the positive infinity too. That means this limit is equal positive infinity. To explain that, look at the graph of the function. This is the graph of the function x cubed. When x approaches to the positive infinity, the function is going to the positive infinity too. That means this limit is equal to the positive infinity. B. Limit when x approaches to the negative infinity, x cubed. Because the degree is odd and its coefficient is positive, that means this limit is approach to the negative infinity. As you can see here, when x approaches to the negative infinity, the function is going to the negative infinity too. That means this limit is equal negative infinity. Check it out. Number 5. Find each limit. A. Limit when x approaches to the positive infinity, x squared. Here this function, its degree is even, so, and its leading coefficient is positive. That means this limit is equal to the positive infinity. That means when x approaches to the positive infinity, x squared approach to the positive infinity too. As you can see here at the graph of this function, when x approaches to the positive infinity, the function f of x approaches to the positive infinity too. That means this limit is equal positive infinity. B. limit when x approach to the negative infinity x square, because it is degree is even, leading coefficient is positive, so this limit is equal positive infinity. As you can see on the graph of the function, limit when x approach to the negative infinity, the function is going to the positive infinity. That means this limit is equal positive infinity. Example number 6. Find each limit. Limit when x approach to the positive infinity. We have two things here. If we want to find the limit, we can do only multiply this plus this plus, and the leading coefficient for the numerator sign and leading coefficient for the denominator, all of them are positive. That means this limit is equal to the positive infinity. But if we want to find the slant asymptote, take a long division. 2x squared minus 4x over x plus 1. 2x squared divided by x is 2x. 2x times x is 2x squared, and 2x times 1 is plus 2x. And subtraction, 2x squared minus 2x squared is cancelling, and then minus 4x minus 2x is equal minus 6x. And now minus 6x divided by x, it becomes minus 6. And minus 6 times x plus 1 is equal minus 6 minus 6. And now by subtraction, the answer be plus 6. And now to finding the limit, write down this limit as this way. First of all, limit when x approach to the positive infinity, open a bracket and write the result of division, which is 2x minus 6. After that, you have here positive, write positive, and you have 6, write it at the numerator, and down rewrite the denominator at the denominator, x plus 1. It becomes 6 over x plus 1. And now, because this function or 2x, its degree is odd and x approach to the positive infinity, this one is approach to the positive infinity. And 6, any constant over x, it is limit when x approach to the positive infinity or negative infinity is equal to 0. That means this limit is equal positive infinity plus 0, which is equal positive infinity. And as we first time we said, positive times positive is positive infinity. And this one, 2x minus 6, is called a slant asymptote. Y is equal to x minus 6 is called a slant asymptote. Example number 6. Find each limits. B. Limit when x approach to the negative infinity. For 2x squared minus 4x plus over x plus 1. We explained this one and founded the slant asymptote. And now to finding the result of this limit, only multiply this negative, and here you have positive, and here you have positive. So negative times positive is equal negative. That means it is equal negative infinity. Example number 6, or check it out 6. Find each limit. Limit when x approach to the positive infinity, minus 2x squared minus 4x plus 1 over x minus 1. To finding this limit, only multiply plus time minus time plus is equal minus. That means this one is equal minus infinity. And to finding the slant asymptote, only make a long division. Minus 2x squared minus x plus 1 divided by x minus 1. Minus 2x squared divided by x is minus 2x. Minus 2x times x minus 1 is equal minus 2x squared plus 2x. Subtracting, this 1 is cancelling, and this one minus x minus 2x is minus 3x. Rewrite plus 1. And now minus 3x divided by x is equal minus 3. Minus 3 times x minus 1 is minus 3x plus 1, 3. And now subtracting, it becomes minus 2. And now minus 2x minus 3, y is equal minus 2x minus 3 is a slant asymptote. Example number 7, find each limit. A, limit when x approach to the positive infinity for sine x. As you know, the value of sine x is between minus 1 and 1. That means the value of sine x is oscillating between minus 1 and 1 when x approach to the positive infinity. That means this limit is not exist. As x approaches positive infinity, the value of sine oscillated between minus 1 and 1. Thus, the limit of x approach to the positive infinity for sine x does not exist. B, limit when x approach to the positive infinity for sine x to the x. Because limit of the sine x is not exist, here we must use the sandwich theorem. The function sine x is between minus 1 and 1. And now we are dividing all sides by x bigger than 0, because we have x is approaching to the positive infinity. That means x is positive. So dividing by x become minus 1 over x less than or equal sine x over x less than or equal 1 over x. And now take the limit of all sides. Limit x approach to the positive infinity minus 1 over x, limit when x approach to the positive infinity sine x over x, and limit when x approach to the positive infinity 1 over x. This one is equal to 0 and this one is equal to 0. Because both sides is 0, that means the limit of x approach to the positive infinity sine x over x is equal to 0 according to the sandwich theory. Check it out 7. Find each limit. A, limit when x approach to the positive infinity cosine x. As we said with the sine x, it's same as cosine x. Because cosine x is oscillating between minus 1, 1, that means this limit is not exist. When x approach to the positive infinity, the value of cosine x oscillates between minus 1 and 1. That means the limit when x approach to the positive infinity cosine x does not exist too. And now B, limit when x approach to the positive infinity cosine x over x. As we said before, because the limit of cosine x is not exist, here we must use the sandwich theory. Cosine x is between -1 and 1. Divided all sides by x, positive than positive, and positive, that means bigger than 0. And after that take the limit, it become 0 less than or equal limit x approach to the positive infinity, cosine x less than or equal to 0. Because both of sides is 0, that means the limit when x approach to the positive infinity for cosine x over x is equal 0 to, according to the sandwich theory. And now we have question number 6, page 136a. Find limit x approach to the positive infinity, 1 minus 2x all square over 2x square plus 1. First of all, to finding this limit, we must open this bracket. It become limit when x approach to the positive infinity. The first one, 1 is square is 1. After that, 2 times 1 times 2x is minus 4x. 2x minus 2x square is 4x square. And now, because the degree of the denominator is equal the degree of the numerator, that means the coefficient of the leading coefficient for the numerator over the leading coefficient of the denominator, it become 4 over 2, which is equal to. This limit is equal to 2. Question number 6. B. Find limit when x approach to the negative infinity for 1 over 2x square minus 1 plus 2x. Be careful here. You have two parts of this function. The first part, which is 1 over 2x square. This part, because you have a constant at the numerator and x at the denominator, so this limit of this function is equal to 0 when x approach to the negative infinity or a positive infinity. And this part is, because it is degree is odd, that means when x approach to the negative infinity, this part goes to the negative infinity. That means this limit is equal negative infinity. And the part minus 1 plus 3x minus 1 plus 3x is y equal minus 1 plus 3x is a slant asymptote. Question number 6, C. Find limit when x approach to the negative infinity for 2x square minus x minus 1 over x, absolute value of x minus 2. First of all, we must define the x minus 2, absolute value of x minus 2. Absolute value of x minus 2 is equal x minus 2 when x is bigger or equal than 2. And it's equal minus x minus 2 when x is less than 2. Because x approach to the negative infinity, that means this x is less than 2. So we take the second part, minus x minus 2. So this limit is changing to limit when x approach to the positive infinity. Rewrite the numerator to x squared minus x minus 1 and open this bracket. Minus x minus times minus is positive, it's become minus x plus 2. And now, because we have here negative and the leading coefficient of the numerator is positive and leading coefficient for the denominator is negative, so negative times positive is negative. Negative times negative is positive 2. That means this limit is equal to positive infinity. Here we reach the end of the lesson. Thank you for watching, and please do not forget to subscribe the page and write your comment if you have any question, and push like button to encourage us. And I will tell you again, there is a link for the exercise of this lesson down at the description. Download it and use it carefully. Thank you for watching again, and goodbye.